Yep. So today we are going to study about a new topic that is relations and functions. You must already have heard about all these terms, like both of these terms. There are not many terms. So yes, you must have heard about both of these terms, right? So now let me tell you that I'm going to change your view or a little expect about relations. Can you tell me what a relation is? Can you define what a relation is? Yes. It was the same thing as we used to define, like she's my mother, okay, she is my brother, she's my teacher, like a student and a teacher relation. It is the same relation we are talking about. And yes, we are going to study that same relation in mathematics as well. Now you will ask me how. How is this possible? Okay. So for what we have answered, what a relation is, then how it is possible? Let me tell you how it is possible. See, you already know about it. Most of the times we have mentioned that I have two lines, let's say M and N. And I say that these two lines are parallel to each other. So what I am doing, I am establishing a relation between two lines. This is the only thing we are doing. We are establishing a relation. Like also we have said M is perpendicular to N. Remember, we have done this so many times and it's perpendicular to N. So what is happening? We are establishing a relation between two lines and saying that they are perpendicular to each other. We are doing the same thing. So this is how we define relation in mathematics. We take two variables and try to find how they are related. Okay. So as mathematician, it is our favorite task to deduct so many things or to make it precise. So we have also made relations precise. Instead, to define a relation, the first or primer thing you will do before starting any topic, before starting any kind of a class, you will define the syllabus. You will define the range of it. So the first thing I'm going to do is define a relation. Okay. So for relation, I need to have two objects and I need to have one property which relates the two objects. I need to have one property, right? This is how the math has made this relation a precise thing. Okay, we need two objects and one property. That's how we are going to define a relation. Now, if I say, okay, I have a relation. Okay, so how? For a relation, I said I require two objects. In mathematics, what those objects be? Those objects will be fixed, will be two different, either they can be a same set, it can be, it can be same set, they can be two different sets, but most importantly, they should be non-empty sets. The most important property there should be, they should be non-empty. There should be some elements in those sets. Okay. So the first thing we're going to learn about is we're going to learn, we are going to learn how to link pair of objects, pair of objects from two sets, from two sets. Okay. In this chapter, three things in this chapter. So the first thing is this, how we are going to link the two pair of objects. Then the second thing is we are going to introduce relation between two objects in the pair. Two objects in the pair. The third thing, and which is also the second heading of this chapter, that is functions. So what function is? Function is a spatial relation, I should say. Let us make it a little spatial or feel good about itself that a function is a spatial relation. This is function. Okay. A particular or specific kind of relation only form a function. Okay. Or qualifies to form a function. We can say it captures the idea of mathematically precise correspondence between one quantity to another. What we are doing, we had sets. First, we had the elements. We grouped them into sets. Now we have sets, so many sets. Now what we are doing, we are grouping them. We are linking them. We are making the pair of the elements in the set. Then we will try to find if there is any relation between the elements which are in pair. Okay. Once we have defined the relation, now I will say, okay, there is some kind of a spatial relation between them. So what we have done, we have we have started from the entire space, or I should say, we have started from the simple space, then we start precising it from the set. Then we start precising, then we again precise it, we form the pair of the objects. Then we form the relation while precising, and then we precise it a little more and form the functions. Okay, so this is the flow of our chapter. This is the flow of our mathematical, I should say. Right. Now, as we talked about, we are going to learn how to link pair of objects. How to link pair of objects. How to link pair of objects. So this is the first thing we are going to learn, and this first thing is known as Cartesian product. Cartesian product of sets. Okay. So as understood, the first thing we are going to do here is we are going to define what a Cartesian product is. Okay. So basically, as I said, we should have two non-empty sets. So given, let us say P and Q are non-empty sets. Non-empty sets. Okay. So the Cartesian product first, how we represent it, is it represented by P cross Q? What is it? It is the set of all ordered pair of elements from P and Q. Nothing difficult, nothing complicated. It is just the ordered pair of elements from P and then Q. What we are doing, we are taking an element from P, putting a comma, then we are taking an element from Q and write those elements into a bracket. That's it. That is what we are doing. Okay, if I mention, what am I doing? I am just writing P cross Q as curly bracket. P is an element from capital P and Q is an element from capital Q. And I'm going to write it as well, like P belongs to capital P and Q belongs to capital Q. This is the order pair. Okay. What does it mean in practicality? What does it mean in practicality? Let me take an example of it. Let me take an example of it. What does this mean in practicality? Let us have two sets. Let us have two sets. Okay. One, the name of set is A, and it contains two colors, let's say red and blue. It is a set of two colors. And let me take another set, which is the set of objects. The set of objects, let's say, are a bag, a coat, and a shirt. We have two sets. This is a set of colors, two colors, and this is a set of objects, right? So, now the question arises, how many pairs of colored objects can be made from these two sets? Okay. So whatever we have, we are trying to increase those things. Like I have these two sets, A and B, colors and the objects. Now I will say how many colored objects I can have from these two sets. From these two sets only. Okay, so the first thing, my object has been inside, like I have these three objects, a bag, coat, and a shirt. And then my colors has been precise also, that I only have red and blue color. So what can I do? I can say that I can have a red bag. I can have a red bag. I can have a red coat. I can have a red shirt. How many colored objects? A red bag, red coat, red shirt. Then what can I have? I can have a blue bag. I can have a blue bag. I can have a blue coat. I can have a blue shirt. So from these two particular sets and these two particular objects, these three particular objects, and among these two particular colors, how many color objects I can have? I can have these many color objects, right? And this is the Cartesian product, the ordered pair. This is how I am going to write. What I said in the beginning, that whenever you are supposed to write the ordered pair, what you are going to do? First, you are going to represent the Cartesian product like this. Then you are going to make a bracket, a curlier one. Then a smaller bracket, you are going to take one element from one set, that is red, then another element from another set. Then same, one element from set A, then another element, that is C, from set B. Then it will be red shirt. Okay, then it will be blue bag. Then it will be blue coat. It will be a blue shirt and a curly bracket closed. This is how you write the Cartesian product. And if I am sure that we understand what is the physical meaning of Cartesian product, right? To understand this, we can go further ahead. I can have one more example. I can take that. See, the second example, in the second example, what I am going to do, I am going to take two elements, let's say A is equals to BL MP, and AA. These are the three states. Three, two. Okay. And the set B is 0, 1, 0, 2, and 0, 3. What is this? It represents the code for license plate issued by these states, like whatever the states given in the first set. Okay. So what happens if these states puts up a restriction? What happens? These states have put up a restriction that the code of the license plate of vehicle should begin with the element of set B. They have said, okay, we are going to issue a license plate to you, but the code of the license plate should begin with the element of set B only. It cannot begin with any another number. So the available pairs, will look something like this. It will look something like this. Like Delhi will be 1%. Delhi BL01. Okay. Then Delhi is asking you to take, it can provide a code 02. Then it can provide a code 03. Okay. I don't know what happened. Why? Okay. Then it can provide a code 03. Okay. Now, MP has also said this. So MP says that it can provide a code as 01. It can provide a code as 02. It can provide a code as 03. MP03. Okay. Then Karnataka is left. I can say Karnataka is also giving. Karnataka is also giving 01. Karnataka is also giving 02. Then Karnataka is also given 03. So these are the available codes for a license plate. Do you understand what I'm talking about? Okay. So this is what? This is nothing but the Cartesian product of the two sets, that's A cross B. Right? You have understood what we are talking about? So this is the Cartesian product. Coming across all of this, we have found there are some remarks of Cartesian product. Like Cartesian product follows some rules. Okay, it follows some rules. After studying the examples, after studying the definition of it, we have come across few rules which are followed by a Cartesian product. There is that those remarks are first. First is two ordered pairs. Two ordered pairs are equal if and only if and only if. So, two ordered pair, let's say A comma B is equals to P comma Q if and only if the corresponding elements are equal. If A is equals to P and B is equals to Q. Only then you can say yes, two ordered pairs are equal. Then only say these two are equal. The second thing we have studied, that the number of elements in A cross B have always been the product of number of elements in A and number of elements in B, right? As we have done C, we did the example for what colors and the objects. So we had two colors and we had three objects. In total, it becomes red bag, red coat, red shirt, then blue bag, blue coat, and blue shirt. So we have we had in total six ordered pairs, right? So how it happened? The total number of elements of A cross B, or the total number of ordered pair we are going to have, that will be equals to n of A, number of elements in A into number of elements in B. Okay. Let's say number of elements in A is n and number of elements in B is s. So this is n into s. Okay. The third one is, if you are taking Cartesian product of three sets, then the ordered pair looks something like A, B, and C. And where A, B, and C, all the three belongs to capital A. I said that the sets can be same or different. The only point it should have, they should not be a non-zero set. They should be a non-zero set. Like they should not be n3 sets. Okay. So this pair is known as ordered triplet. This pair is known as ordered triplet. Okay. Now, if I ask you a question according to this, let's see the example says, if I have x plus 1, if I have an ordered pair which says x plus 1, comma, y minus 2 is equals to c, comma 1. I'm saying this ordered pair is equal. Then what is the value of x and y? Then we have to find the value of x and y. Okay. So as we have studied in the first property that these two are only equal when the corresponding parts are equal to each other. That means x plus 1 is equals to 3. That will give us x is equals to 2. And the corresponding part, that means y minus 2 is equals to 1. It is equals to the bigger one. Y minus 2 is equals to the 1. So y comes out to be equals to 3. Okay. So in this session, we have gotten the overview, right? We have gotten the overview of what this entire chapter contains. Overview. We have gotten the overview what this chapter contains. Then what? Then we have gotten an idea about relation. And what are the elements required for a relation? Then we studied how can we link two elements of a set, or how can we link elements of two sets, right? So we have studied about the Cartesian product and their properties. There are three properties, 1, 2, and 3. Okay, so I will finish the session here. In the next session, we are going to study about relation. Okay, and I am sure that you will solve few questions about the Cartesian product, and you will ask me the doubt in the next session. Okay. Thank you so much. Thanks for joining the class.